Hi, today I'm going to go over repeating decimal to fraction. Type 1, one repeating decimal. Type 2, multiple digits repeating. And I do have some examples, as you could see from the screen. Let's get started. Repeating decimal to fraction. Type 1, one repeating decimal. A good example, a first example for repeating, I could start with 0.1, 0.2. I started with 0.5. 0.5 repeating means 0.555 all the way. Those three dots at the end means it keeps going. We call it x. So x equals 0.5555 repeating. Notice the decimal point is in red. I'm trying to let you stay focused on the decimal point because that's one of the main things in repeating decimal to convert it to fractions. You need to align the decimal and such that the right hand side is equivalent and subtract and you get 0. Let me show you what do I mean. Now, because it's one digit, when you have one digit repeating decimal, you multiply by 10 and look what happens. The decimal gets moved to the right one place if you multiply by 10. If you multiply by 10 both sides, this number right here becomes 5 point. As you could see, I'm aligning the decimals right here and we're gonna subtract. On the left hand side, subtract these two equations from each other. 10x minus x will give me 9x. Right hand side, 5 minus 0 is 5, and all these 5s minus these 5s will cancel, so it's like 5.0. Divide both sides by 9 to get x alone by itself, and I have x equals 5 over 9. That should do it for one digit. So we didn't have to do like another one, 0.2 and 0.3 or 0.7. They're all the same. Let's take two digits, which is type 2. Type 2. If you have 0.64 repeating, that is in a different way, 0.64, 64, 64, and so on. Let's call it x. This time, I'm not going to multiply by 10 because I have two digits repeating. I'm going to multiply by 100. When you multiply by 100, you always want to know like what will do it. By 10, by 100, by 1,000. We're going to see that next. You just need to keep in mind after the decimal that the right hand side cancels. That's one of the main ideas. Everything here cancels. So when you subtract those two equations that you build, we don't have any decimals. So that will do if you multiply by 100. Let's subtract these two equations. Left hand side becomes 100x minus x, which is 99x. Right hand side 64 minus 0 is 64, and all these ones will cancel. Divide both sides by 99 and that will do it. So the answer is 64 over 99. Here's an example, one more. But this time, the left-hand side is not 0 like 0.64 repeating. It's 3.27 repeating. Well, 3 is not actually a problem. It's not in my way. My focus is on the right-hand side. I need the right-hand side to be the same amount to be cancelled. So, if we call this x 3.27, 27, 27, meaning 27 repeating, and multiply by 100 because I have two digits, I notice that the decimal point, if you multiply this by 100, goes right here. Moves to the right two places. So what comes after the decimal is also 27, 27, 27. And that will help focus here and cancel. So let's subtract these two equations. Left hand side is 99x, right hand side 327 minus 3, which is 324. divide both sides by 99 to leave x alone, and that's all what we do always. We get the answer. So x equals 324 divided by 99. Of course, you could test it for practice using a calculator, and that should do it. Now, the next example is a 2-digit, which is type 2, but it's a little bit different, and you need to be careful and pay attention to it. It's 3.5, then 26, 26, 26, 26. So the 26 are repeating, but there is a 5 in my way. The trick is always multiplying by multiples of 10 after you call it x, such that after you align the decimal points, everything on the right side cancels. So if you multiply this x that we are calling it 3.52, 62626 by 10, that's not gonna work. And if I subtract, look at this, left hand side I could subtract 35 minus 3 and 10x minus x, but look after the decimal, 2 minus 5, 6 minus 2, 2 minus 6, 6 minus 2. It's not practical. It doesn't work. So keep the 10x. Why we want to keep the 10x? Because the right side of the decimal is a repeating pattern, 26, 26, 26. If you multiply x by 1,000, I move the decimal 3 places, 1, 2, 3, and I get 262626 again. This is what I mean. Okay? This is my focus, the 26 repeating. So I have 10x. I moved the 5 out of my way. I need to multiply by a number multiple of 10. In other words, think how many times you need to move the decimal such that you get something like that. So you could move it, align the 26 together, the repeating 26, then notice how many times you moved it. That's a 3 times, which means I need to say on the left that I was multiplying by 1,000. Hopefully that was clear, and I'm not making it lengthy. It's a game. You need this to happen. That's why I'm boxing it. And you need to know how many times you need to move the decimal, which translates to multiples of 10. 10, 100, 1,000, and so on. Now let's subtract. 1,000x minus 10x is 990x. The right hand side, 3,526 minus 35 is 3,491. Now I could do this by hand as I'm recording, like subtract 6 minus 5, and when you subtract 2 minus 3, I slash the 5 and borrow 1 from the 5 and so on, or grab a calculator, but that's not my style. I know you could do it and believe on those subtractions unless if I make a mistake. The idea that I'm trying to deliver here is writing the notes with colors in a clean way, as you could see, with boxes, saves some time from recording. This way I could cover more examples in less time. And I believe every student that wants to get a math idea from a lecture recorded video, they want to watch a video and get to the point. They want to watch a video that is less minutes and has enough information. And that's my style. I tried a whiteboard and I tried different ways, document camera, but it takes longer. But that's mainly what I'm focused on. Hopefully you appreciate it, and let's move on. So that was a main example. I know I'm taking more time on this example, but it was worth it. This is a tricky one. If you teach students like 1 digit repeating, 2 digit repeating, and you give them this one without showing you an example, they're gonna struggle, or it's gonna slow them down. So that was a good example in my idea. So dividing both sides by 990, I get 3,491 over 990. Now enough side talk, and let me show you some tricks. In classrooms, I don't teach straightforward talking to the camera. It looks like I'm when I'm recording these videos, I'm kind of like strict and more focused, and I don't joke around. But I don't have time to joke around recording videos. That's mainly what I try. I'm trying to save you some time. Let me show you some tricks and get to the topic. Everything in math is about patterns. Repeating decimal to fraction trick, which is, I call it shortcuts or looking for patterns. After you see the 0.5, which is my first example, repeating, you notice that it was 5/9. If you do another example like 0.1 repeating, you'll get 1/9. So there is a pattern. 2/9, 3/9, which reduces to 1/3, 4/9. See, I'm not even reading this, I'm trying to save you some time. 5/9, 6/9, which reduces to 2/3, 7/9, 8/9, 9/9, which is equal to 1. And that is a proof, one of the proofs why 0.9 repeating is 1. It's right there. You could do the x and multiply by 10 and subtract and show people that 0.9 repeating is 1. So this box or this table is for 1-digit repeating. 2-digit repeating will be right here. I'm saving the time. I'm writing everything down. 0.12 repeating will be, if you do it and multiply by 100 and subtract, we had the 64 repeating, 12/99. 0.34 repeating, 34/99. What do you think 0.5157 is repeating? It's going to be 157/999. Same thing for 234 repeating, 234/999, and the story continues. Let's move on to another pattern. In case the 1 repeating is after the 0.0, like in the 1th, starts with the hundreds place and keeps going. It's not the same like that exactly, but there's a pattern right here also. Do the math, use x and multiply, you get 1/90. So if this is 1/90, this will be 2/90, and this will be 3/90. Of course, you could reduce. 3/90 will be 1/30. Keep going. 0.07 repeating will be 7/90, and so on. Now let's do an example. Let's pick on 0.02 repeating. This example right here. So we call it x. So x is 0.0222 all the way. Because I have 1-digit repeating, I'm going to multiply by 10. I have 0.22. If I put x underneath it and I try to subtract, notice that decimal point right here has a 0 after it. So I need 2's. I need them to cancel. So I'm going to multiply x by 100. The decimal is going to move once, another 1 right here. So it's going to be 2.2 repeating. This is the main idea that I mentioned earlier. As long as you build it, everything is going to work out. Subtract both sides. Left hand side is 100x minus 10x, which is 90x. And right hand side is just 2. The right part of the decimal cancels. 2 minus 0 is 2. Divide both sides by 90. 2/90, which reduces to 1/45. Okay? Now, 2 more examples and we'll be done. 8.7 repeating. So I have the 7 repeating as 1-digit repeating. The 8 is not really a problem. We're going to multiply by 10 after we call it x. And put it on top so we could subtract. I move the decimal once after I multiply by 10. The right hand side cancels, and that's exactly what I want. Let's subtract both sides. I get 9x on the left 87 minus 8, which is 79. This cancels. Divide both sides by 9. And I get x equal 79 over 9. And that's the answer. 8.7 repeating is equal to 79 out of 9. Here's a bonus. I know we could do 2.5 repeating just like the previous example. But I want to show you another way. The more that you know about numbers, the more that you could get to answers, sometimes in a short way, or I call it like more skills and more confidence in what you're doing. More ways is better than just one way. Here's 2.5 repeating. 0.5 repeating, we know it from the first example. It's 0.555 all the way. We did this on the side and we came up with 5 out of 9. And it was built in the table for the trick or the shortcuts. So knowing this, I could think about the 2.5 repeating as 2 and, that's my and, which is plus 0.5 repeating, which means 2 plus 5 out of 9, because that is 5 out of 9. Differently, I could say it's 2 and 5 nines without the plus sign, because that means the same thing. 2 plus 5 nines means 2 and 5 nines, which is right here. That's 2 and 5 nines. Now we could convert this mixed fraction to improper fraction. How? You could multiply the 2 times 9, and once you're done, add the 5, and that becomes your new numerator. This is what I mean. 2 times 9, then you add 5. That's 18 plus 5, 23. That's my new numerator, with the denominator as 9. So 2.5 repeating is 23 out of 9, and I would say that should do it. We're done. Thank you. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.